Before going to the rational numbers, we shall see that how the number system has been developed. We observe that the number system has been developed from the set of natural numbers. Look at the balls. We begin the counting with 1 and then 2 and then 3 and so on. There are 10 balls. The numbers we use to count are called counting numbers or natural numbers. Natural numbers are 1, 2, 3, 4 and so on. Mr. John has $10,000 on his bank account. He transferred the $10,000 from his account to purchase a new plot. How much amount is there in his account? He has zero balance. We observe that there is a number 0 which is not a natural number. If we subtract two equal natural numbers, we get 0. When we include 0 with the natural numbers, are called whole numbers. Look at the buttons showing numbers -2, -1, 0, 1, 2, 3 and 4 on the button panel of the lift. We know about 0, 1, 2, 3 and 4. What about -2, -1? -2, -1 are called negative numbers. When we include negative numbers to the whole numbers, then those numbers are called integers. We use negative integers to express temperatures and profit and loss, etc. Further, we use fractions, decimals. For example, 1/4 of a cake, half of a pizza, 54.42 kilometers, etc. There are some numbers between two neighboring integers. Example, 1/2 is situated between 0 and 1. 1/2 is greater than 0 but less than 1. In the same way, 2/1/3 is situated between 2 and 3. It is greater than 2 but less than 3. Similarly, on the other side of 0, that means left side of 0, between two negative neighboring integers, there are some numbers. Example, -1/2, -2.5, -1 3/4. -1/2 is located between -1 and 0. -1/2 is greater than -1 but less than 0. -1 3/4 is located between -1 and -2. It is greater than -2 but less than -1. When we combine integers and fractions together, are called rational numbers. The numbers of the form p by q, where p and q are integers and q is not equal to 0, are called rational numbers. Let us see the examples of rational numbers. Points to remember. 1. Every natural number is a rational number. Example, 3 can be written as 3/1. Here, 3 and 1 are integers. 2. 0 is a rational number since 0 equals to 0/1. 3. Every integer is a rational number. Example, -5 can be written as -5/1. Here, -5 and 1 are integers. 4. Every fraction is a rational number. Example, 3/5 and 5/9. Positive rational numbers. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. Example: -11 by -13 and 7 by 12. Negative rational numbers. A rational number is said to be negative if its numerator and denominator are such that one of them is a positive integer and the other is a negative integer. Example: -2 by 9 and 13 by -15. Summary. For long journey trips, generally we prefer the transport as train transport, as this is comfortable and most economical. We know that the distance from one station to another station is a rational number. Representation of integers on number line. The number line of integers consists of negative numbers, 0, and positive numbers. Positive numbers which are on the right side of 0 and negative numbers which are on the left side of 0. The value of the integer increases when we move towards right from 0 and decreases when we move towards left from 0. Like integers, we can also represent rational numbers on number line. And let us now represent 1 by 2 and -1 by 2 on the number line. Now set off unit distance points P and P' respectively. Then P represents the integer 1 and P' represents -1. Now divide OP into two equal parts and let A be the midpoint of OP. Point A represents the rational number 1 by 2. Similarly, the point A' represents the rational number -1 by 2. Now, let us represent 4 by 5 and -4 by 5 on the number line. Now, divide OP into 5 equal parts because the denominator is 5. OA be the segment showing 4 parts out of 5 parts. Then the point A represents the rational number 4 by 5. Similarly, the point A' represents the rational number -4 by 5. Representation of an improper fraction on number line. For example, 14 by 3. Convert 14 by 3 into mixed fraction as 4 and 2 by 3. From O, set off unit distance points P, Q, R, S and T respectively. As 4 and 2 by 3 lies between S and T, divide ST into 3 equal parts and then take 2 parts out of these 3 parts and mark it as A. Then A represents the rational number 14 by 3. Similarly, A' represents the rational number -14 by 3. Similarly, we can plot any rational number on number line. Summary. an international school is going to conduct a cricket tournament for their children, and there are two stadiums nearby the school. Stadium 1 is at 11 by 3 kilometers and Stadium 2 is at 13 by 4 kilometers. Then which stadium is more convenient for children to travel from school? In order to solve this type of problems, we need to learn comparison of rational numbers. Compare 3 by -8 and -7 by 12. Step 1. Express each of the two given rational numbers with positive denominator. 3 by -8 equals to -3 by 8. Step 2. Take the LCM of these positive denominators. Step 3. Express each rational number with this LCM as the common denominator. -3 by 8 equals to -3 multiplied by 3 by 8 multiplied by 3 equals to -9 by 24. -7 by 12 equals to -7 multiplied by 2 by 12 multiplied by 2 equals to -14 by 24. So, -9 by 24 is greater than -14 by 24. Therefore, -3 by 8 is greater than -7 by 12. From the above, we observe that converting each of the given rational numbers with common denominator is somewhat lengthy and more calculations. So, to avoid this, we use an alternate shortcut method. Let us consider two rational numbers a by b and c by d. Here, b and d are positive integers. Cross-multiply the given two fractions. Find the cross products AD and BC. If AD is greater than BC, then A by B is greater than C by D. 2. If AD is less than BC, then A by B is less than C by D. 3. If AD is equal to BC, then A by B is equal to C by D. Now, let us compare -6 by 7 and -3 by 4. Cross-multiply the rational numbers. -6 multiplied by 4 equals to -24 and 7 multiplied by -3 equals to -21. -24 is less than -21. Therefore, -6 by 7 is less than -3 by 4. Summary. In a men's 100-meter World Athletics Championship, sprinter A completing 100 meters lap in 9.58 seconds and won gold medal. Sprinter B completing in 10.59 seconds and won bronze medal. So, there will be a sprinter C who won silver medal and completing in between 9.58 seconds and 10.59 seconds. Can you tell the integers between -3 and 2? There are -2, -1, 0 and 1. Now, can you find any integer between 2 and 3? No. Between any two consecutive integers, we can find rational numbers. Observe that the rational numbers 1 by 5, 2 by 5, 3 by 5 and 4 by 5 are lying between 0 and 1. Can you find any rational number between 1 by 5 and 3 by 5? Yes. Rational numbers 2 by 5 lies between 1 by 5 and 3 by 5. Suppose if we write 1 by 5 as 100 by 500 and 2 by 5 as 200 by 500, then we can find some more rational numbers. If we proceed like this, we can find many more rational numbers between any two rational numbers. We can say that unlike natural numbers and integers, there are countless irrational numbers between any two given rational numbers, and this leads to the density property of irrational numbers. We can find rational numbers using different methods, like by generating equivalent rational numbers and mean method or finding average. Let us solve some examples. Find a rational number between 2 by 3 and 3 by 4. Take the LCM of 3 and 4. It is equal to 12. 2 by 3 can be written as 8 by 12. 3 by 4 can be written as 9 by 12. Now, find the rational numbers between 8 by 12 and 9 by 12. 8 by 12 can be written as 80 by 120. 9 by 12 can be written as 90 by 120. So, the 9 rational numbers between 80 by 120 and 90 by 120 are Find a rational number between 1 by 5 and 1 by 2. The average between any two numbers a and b is a plus b by 2. The average between 1 by 5 and 1 by 2 is 7 by 20. Summary. The distance between pond and tree is 27 by 2 kilometers, and the distance between tree and hillock is 33 by 2 kilometers. Then, the distance between pond and hillock is 30 kilometers. Here, 27 by 2, 33 by 2 are two rational numbers, and the total distance 30 is also a rational number. The sum of two rational numbers is a rational number. Let A and B belongs to a set A and C is equal to a dot circle B, where dot circle is a binary operation. If C belongs to A, then set A is said to be closed under operation dot circle. 2 by 5 plus 1 by 5 equals to 3 by 5. And observe that 2 by 5, 1 by 5 and 3 by 5 are rational numbers. 1 by 2 plus minus 4 by 5 equals to minus 3 by 10, and observe that minus 3 by 10 is also a rational number. The distance between a school and lighthouse is 46 by 3 kilometers. There is a golf court on the way. The distance between golf court and lighthouse is 22 by 3 kilometers. Then, the distance between school and golf court is 24 by 3 is equal to 8 kilometers. 4 by 7 minus 3 by 5 equals to minus 1 by 35, and observe that minus 1 by 35 is also a rational number. Minus 6 by 11 minus 6 by 11 equals to 0, and observe that 0 is also a rational number. Product of 2 by 7 and minus 4 by 5 equals to minus 8 by 35, and observe that minus 8 by 35 is also a rational number. Product of 3 by minus 5 and minus 2 by 9 equals to 2 by 15, and observe that 2 by 15 is also a rational number. Set of rational numbers is closed under multiplication. 9 by 16 divided by minus 5 by 8 equals to minus 9 by 10, and observe that minus 9 by 10 is also a rational number. 6 by 25 divided by minus 3 by 5 equals to minus 2 by 5, and observe that minus 2 by 5 is also a rational number. Can we say that the rational numbers are closed under division? No, because division by 0 is not defined. Set of rational numbers is not closed under division. Summary. The number of apples in your bag is the same if initially you have 3 and then add 6, or as it is if you have 6 initially and then add 3. If you walk 1 kilometer north and then 500 meters east, you end up in the same place as you would have if you had walked 500 meters east and then 1 kilometer north. Here, we get the same result or output in both the situations, irrespective of the order of occurrence. If A and B belongs to a set A and A dot circle B is equal to B dot circle A, where dot circle is a binary operation, then set A is said to be commutative under operation dot circle. Under addition, look at the addition table. 1 by 3 plus 5 by 6 equals to 7 by 6, and similarly 5 by 6 plus 1 by 3 equals to 7 by 6. Minus 3 by 5 plus 1 by 3 equals to minus 4 by 15, and similarly 1 by 3 plus minus 3 by 5 equals to minus 4 by 15. Therefore, addition is commutative for rational numbers. Now, let us verify this property under subtraction. Look at the given table. Minus 3 by 7 minus 4 by 5 equals to minus 43 by 35, but 4 by 5 minus 3 by 7 equals to 43 by 35. 1 by 2 minus 4 by 5 equals to minus 3 by 10, but 4 by 5 minus 1 by 2 equals to 3 by 10. That is, for any two rational numbers a and b, a minus b need not be equal to b minus a. Therefore, rational numbers are not commutative under subtraction. Look at the table. 1 by 4 multiplied by minus 2 by 3 equals to minus 1 by 6, and similarly, minus 2 by 3 multiplied by 1 by 4 equals to minus 1 by 6. Product of 3 by 5 and 1 by 4 is 3 by 20, and similarly, the product of 1 by 4 and 3 by 5 equals to 3 by 20. For any two rational numbers, a and b, a multiplied by b is equal to b multiplied by a. Therefore, rational numbers are commutative under multiplication. Now, let us verify the commutative property under division. Look at the table. Minus 1 by 3 divided by 2 by 5 equals to minus 5 by 6, but 2 by 5 divided by minus 1 by 3 equals to minus 6 by 5. 2 by 5 divided by minus 3 by 4 equals to minus 8 by 15, but minus 3 by 4 divided by 2 by 5 equals to minus 15 by 8. Therefore, rational numbers are not commutative under division. Summary. In a certain train, there is wagon A, wagon B, and engine. We can attach engine and wagon A first, and then attach the wagon B to it. It gives the same arrangement if we arrange wagon A and wagon B together first, and then attach it to the engine. Here, we observe that the grouping and order of attachment, association of components, doesn't make a difference in the final arrangement. If A, B, and C belongs to a set A and A dot circle B whole dot circle C is equal to A dot circle B dot circle C, where dot circle is a binary operation, then set A is said to be associative under operation dot circle. Consider three rational numbers 3 by 5, minus 1 by 4, and 2 by 3. Let us consider the expression 3 by 5 plus minus 1 by 4 plus 2 by 3 is equal to 3 by 5 plus minus 1 by 4 plus 2 by 3. First, solve the LHS part. 3 by 5 plus minus 1 by 4 plus 2 by 3 is equal to 12 plus minus 5 by 20 plus 2 by 3 equals to 7 by 20 plus 2 by 3 equals to 21 plus 40 by 60 equals to 61 by 60. Now, let us verify the RHS part. 3 by 5 plus minus 1 by 4 plus 2 by 3 equals to 3 by 5 plus minus 3 by 8 by 12 equals to 3 by 5 plus 5 by 12 equals to 36 plus 25 by 60 equals to 61 by 60. Therefore, we can say that rational numbers are associative under addition. Now, let us check this property under subtraction. Let us consider these two expressions, minus 5 by 6 minus 2 by 3 minus 3 by 4, and minus 5 by 6 minus of 2 by 3 minus 3 by 4. Let us solve the first expression. Minus 5 by 6 minus 2 by 3 minus 3 by 4 equals to minus 5 minus 4 by 6 minus 3 by 4 equals to minus 9 by 6 minus 3 by 4 equals to minus 3 by 2 minus 3 by 4 equals to minus 6 minus 3 by 4 equals to minus 9 by 4. Now let us solve second expression. Minus 5 by 6 minus of 2 by 3 minus 3 by 4 equals to minus 5 by 6 minus of 8 minus 9 by 12 equals to minus 5 by 6 minus of minus 1 by 12 equals to minus 5 by 6 plus 1 by 12 equals to minus 10 plus 1 by 12 equals to minus 9 by 12. Therefore, we can say that rational numbers are not associative under subtraction. Similarly, for any three rational numbers a, b, and c, a into b into c equals to a into b into c. Rational numbers are associative under multiplication. For any three rational numbers a, b and c, a divided by b whole divided by c is not equal to a divided by b divided by c unless c equals to 1. Rational numbers are not associative under division. Summary. Our computer programming is full of numbers and codes. We generate many algorithms based on the properties of numbers. Let's learn some properties of numbers. If A and E belongs to set A and A dot circle E is equal to A is equals to E dot circle A, where dot circle is a binary operation, then the element E of set A is said to be an identity element under operation dot circle. Additive identity. Consider a rational number minus 4 by 5. Add 0 to this number. What is the sum? The sum is minus 4 by 5. Look at one more example. Minus 2 by 3 plus 0 equals to minus 2 by 3 equals to 0 plus minus 2 by 3. From the above examples, we can say that the sum of any rational number and 0 is the rational number itself. Therefore, 0 is called the additive identity for rational numbers. Let us consider a rational number 4 by 5. What number should we multiply with 4 by 5 to get 4 by 5? 1 is the answer. If we multiply 1 with any rational number, then the product is the rational number itself. That is, if a by b is any rational number, then a by b multiplied by 1 equals to a by b equals to 1 multiplied by a by b. Therefore, 1 is called multiplicative identity of rational numbers. If a dash and e belongs to set A and a dot circle a dash is equal to a dash dot circle A, where E is an identity element of dot circle, a binary operation. Then the element a dash of set A is said to be an inverse element of A under operation dot circle. Additive inverse. Consider a rational number 4 by 5. What should we add to 4 by 5 to get the sum as 0? Minus 4 by 5. Look at this example. Minus 2 by 3 plus 2 by 3 equals to 0. If a by b is a rational number, then there exists a rational number minus a by b such that a by b plus minus a by b equals to 0. Here, minus a by b is the negative or additive inverse of a by b. In the given examples, minus 4 by 5 is the additive inverse of 4 by 5. Consider a rational number 2. By what number should we multiply it to get the product as 1? The answer is 1 by 2. 2 multiplied by 1 by 2 equals to 1. Look at the example. Minus 3 by 5 multiplied by minus 5 by 3 equals to 1. 1 by 2 is the multiplicative inverse of 2. Minus 5 by 3 is the multiplicative inverse of minus 3 by 5. Therefore, if a by b is a non-zero rational number, then b by a is its multiplicative inverse or reciprocal. Let us consider an example. Minus 4 by 7 multiplied by 0 equals to 0 multiplied by minus 4 by 7 equals to 0 into minus 4 by 7 equals to 0. That is, the product of 0 and any rational number is 0, and hence this is multiplicative property of 0. Summary. Height of a building is 18 2 by 5 feet. The height of a tree near the building is 11 2 by 3 feet. What is the difference in the heights of the building and the tree? Height of a building and tree are given. It is required to find the difference between the two heights. The difference between two heights is equal to 18 2 by 5 minus 11 2 by 3. 92 by 5 minus 35 by 3 equals to 276 minus 175 by 15 equals to 101 by 15 equals to 611 by 15. Therefore, the difference between two heights is equal to 611 by 15 feet. Ram has 5 1/4 pizzas. He wants to distribute 3/4 of pizza to each of his friends. Find the number of friends he can distribute the pizza. Total parts of a pizza and part of a pizza distributed to each friend is given. Required is to find the number of friends that he can distribute the pizza. For that, we need to divide the total parts of a pizza by part of a pizza distributed to each friend. The number of friends equals to 5 1/4 divided by 3/4 equals to 21/4 into 4/3. Cancel the common factors so that we get 7. Therefore, he can distribute 3/4 of a pizza to 7 friends. A car is moving at an average speed of 46 4/5 km per hour. How much distance will it cover in 7.5 hours? Average speed of the car and the time taken by the car are given. Required is to find the distance covered by the car. We know that the distance equals to speed into time. Distance equals to 46 4/5 into 7 1/2.